Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video I will attempt to predict the income of a person given some attributes. Now before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. I should also say that the material in this video is purely educational and is meant to show a simple example of using machine learning to make predictions with Python. Okay, so I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So to get started writing this code, go ahead and click on File, then click on New Notebook, and a new tab will open up for you, and then a new cell. And in this cell, I'm going to put in a description about the program. So that way I could just look back at this description and then know what the program is supposed to do or what it is about. So I'm just going to type here, this program attempts to predict a person's salary based on some attributes. Okay, so next I'm going to go ahead and create a new cell by clicking this code button in the top left, and in this cell I'm going to import the libraries. So I'm going to import pandas as PD, I'm going to import numpy as np, and then from sklearn.model underscore selection, I'm going to import train underscore test underscore split, and from sklearn.ensemble, I'm going to import gradient boosting classifier. All right, next I'm going to import Seaborn as SNS, and I'm going to import matplotlib.pyplot as BLT, and then I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. All right, so let's give it a little time, and it looks like I'm good. So I'm going to go ahead and create a new cell, and now in this cell I plan on loading some data. So I'm going to load the data, and to do this I need to use Google's library. So from google.colab, I'm going to import files, and I'm just going to type files.upload, and I'm going to run this cell and then click on choose files, and I'm going to upload this file here. So I'm just going to click open, and this may take a little time. So right now we're at about less than 20%. So I'm just going to give this some time and come back. Okay, so it looks like the file is done uploading. So let's go ahead and create a new cell. And now in this cell, I plan on reading the data. So I'm gonna read the data. So I'm gonna create a variable called df and set it equal to pd.read underscore csv, and then I'm going to input the name of that file. So I'm just gonna come up here and I'm gonna highlight it, and I'm gonna copy it using Control C, and then come down here and paste it using Control V, and then I'm just going to type show the data. So we're going to show that data. So to do that, just type df, and let's go ahead and run this cell. Okay, so now we can see the data, and we can see a few columns up here. So we can see age, work class num, education, education num, marital status num, occupation num, so on and so forth. So I'm just going to go all the way to the end here, and we're going to take a look at the target column. So this column here will tell us if this person is making over 50,000 or not per year. Okay, so it's telling us their income. And any column that you see with the underscore num are number values, or contains only number values, and those number values are associated with the column to the left of it, and they are correspondent. So for example, anytime I see United States here for native country, the native country number will be 39. So United States corresponds to the number 39 here. And let's see if we can see a different example. Nope. So let's look at another column like sex. So here we can see female, and the number associated with female is 0. So we can look at that sex num column, and we can see the value 0. And let's see for male, that value will be 1. Okay. So I think you get the idea here. So let's go ahead and create a new cell, and we're going to use that later on in the program. So now in this cell, I want to get a count of each education type. So education is one of the columns there. So to do that, just type df and then put in education dot value underscore counts. And let's run this. I think that should be good. All right, so here we can see that the majority of the data set contains individuals with a high school graduate or with a high school graduate degree. Okay, so about 10,501, and then we have about 7,291 rows that have some college. So these are individuals that have some college degree, and about 5,355 that has a bachelor's degree, and then we can see master's, so on and so forth. Okay. All right. So now that we can see these counts, let's look at it more visually. So here we're going to visualize the count of each education type. So to do that, just type sns.countplot, and then we're going to input df education, and I will give this a label. Set the label equal to count, and then we're going to change the x ticks as well. So I'm going to type pt.x ticks, and I'm going to set the rotation equal to 90 degrees. And let's go ahead and run this. All right, so now we can see our x ticks here, right? So everything is set on 90 degrees, and now we can get a visual of that education count, and we can visually see that the majority of the people in this data set have a high school degree, right? It's right here. All right, so I think that looks really nice. Let's go ahead and create a new cell, and now in this cell I want to get the count of income above and below 50K for each education type. So I'm just going to type sns.countplot, and I'm going to set x equal to our education column, and I want the hue to be our income from the income column, and then I'm going to set order equal to df education dot value underscore counts dot index, and then I want the data that we're going to be using to be our data frame, that's df. Okay, and then I'm going to set those x ticks to be rotated 90 degrees again. So I'm going to type pt dot x ticks, and I'm going to set rotation equal to 90, and I'm going to type pt dot show. All right, so let's go ahead and run this, and it looks like I misspelled pt dot show, and let's run this one more time now. Okay, so now we get a bivariate chart. So we can see that the majority of people with a high school graduate degree, the majority of them are making an income that's less than or equal to 50K. And it looks like the bachelors or people with a bachelor's degree are doing a lot better than people with just a high school degree. And people with a master's degree, it seems like the majority of them are actually making more than 50K, which is interesting. And if we go down even further, we can see that the doctorate or people with doctorate degrees are also making more than 50K. The majority of them are making more than 50K. All right, so it's pretty interesting, and we can do a whole bunch of analysis with this data. But let's go ahead and continue with this program. Let's create a new cell. And now in this cell, I want to get the count of each value within the data. So I want to get the count of each income value. Okay. All right. So to do that, I'm just going to type df, and I'm going to put in income here dot value underscore counts, And let's go ahead and run this. Okay, so now we can see that the majority of this data set contains individuals that are making less than 50K. And then we can see that the rest of the data has individuals that are making more than 50K. All right, but this is very, very unbalanced. You really want it to be about 50-50, and this is definitely not the case for this data set here. All right, so let's go ahead and create a new cell. All right, now in this cell, I want to, let's see, I want to visually get that count of the income. So let's go ahead and do that now. So just type SNS dot count plot, set X equal to income. And actually, you know what I'm going to do is I'm going to come back up here where we kind of already did that. I'm going to highlight all of this and I'm going to copy using Control C, come back down here, and I'm going to paste it here using Control V, and I'm going to change just a few values. So instead of education here, I'm going to put income, and the hue can actually stay the same, and here needs to be income, and I think that that'll do it. So let's go ahead and run this. All right, there we go, and I'm going to put some comments as well. So here I'm just going to put visually show the count of each income type above and below 50K. All right, so now we can see it more visually, right? For the count of individuals who are making more than 50K and the count of individuals who are making less than or equal to 50K. All right, so that looks good, and again, the data is very much so unbalanced, and I don't think that that's a good thing. So let's go ahead and create a new cell. All right, so now in this cell, I'm going to create a list of categorical columns to keep. So I'm going to create a variable called categorical underscore keep underscore columns. That's probably not a great name for this, but that's what I'm going to use for now. I'm going to set it equal to an empty list, but let's go ahead and populate that empty list. So I'm going to input age and work class and education. Let's put in relationship and marital status. Okay, so these are all column names from the data set. All right, and then I want to show the data. So I'm going to type df, and I only want to show those categorical columns. So I'm going to put in categorical underscore keep underscore columns. All right, so let's go ahead and run this. And now we can see just the columns that we wanted to see, those categorical columns that I want to keep. All right, so that looks good. But to train the model, I'm going to be using the number equivalent to these values here. So let's go ahead and create a list of columns to keep for those number values. So let's create a new cell. All right, and now in this cell, I'm going to create a correlated, and I may be misspelling that there, correlated, but create a correlated number list of columns to keep from the categorical columns. And we're going to do this to train and test the model. All right, so I'm going to create a variable called keep columns, and I'm going to set this equal to an empty list at first, but I'm going to input everything that we input up here. So I'm just going to highlight all of this. I'm going to copy it using Control C. I'm going to come back down here, and I'm going to paste it using Control V, and I'm going to change just a few things. So I'm going to put underscore num here, and underscore num here, and underscore num here, and underscore num here. All right, and then I want to show the data. So I want to show only those columns that I want to keep. So that's keep underscore columns, and let's run this. Okay, so now we're seeing the number equivalent of this data set up here. All right. Okay, let's go ahead and create a new cell. And now it's time to prepare the data for our model. So I want to split the data set into a feature or independent data set that we're going to call X, and a target or dependent data set that we're going to call Y. All right, so I'm going to create a variable called X. I'm going to set it equal to df keep underscore columns dot values, and I'm going to create a variable called Y. I'm going to set it equal to df income dot values. So this is our target. All right, so let's go ahead and run this, and that looks good. I'm going to create a new cell. Now in this cell, I'm going to do more splitting of the data. So I'm going to split the data again, but this time into 80% training and 20% testing data sets. Okay, so I'm going to create a few variables. I'm going to create X underscore train and X underscore test and Y underscore train and Y underscore test, and I'm going to set them equal to train underscore test underscore split, and we're going to input the X data set and the Y data set, and then we're going to give this a test size. So I need to set this test size equal to 20% or 0.2. Okay, so let's go ahead and run this, and let's create a new cell. All right, now in this cell, I'm going to create and train the model. So I'm going to create a variable called GB underscore CLF, and that's going to be short for gradient boosting classifier. And I'm going to set this equal to gradient boosting classifier, and we're going to give it a number of estimators. So n underscore estimators will be equal to 20, and then the learning rate will be equal to 1, and the max features will be equal to 2, and the max depth will be equal to 2 as well, and the random state I will just put in 0. That value really doesn't matter too much. So let's go ahead and train the model now. So just type GB underscore CLF dot fit, and fit is another name for train, and then input the training data set. So that's X underscore train and Y underscore train. Okay, and I think that looks good. So let's go ahead and continue here. So we're going to show the model score on the training and testing data sets. All right, so I'm going to print accuracy score training and then put a colon here. I'm going to put GB underscore CLF dot score X underscore train and Y underscore train. All right, and I'm just going to highlight all of this and copy using Control C and paste it right here using Control V and change just a few things. So here I'm going to put testing, or how about just test, and then we're going to change this here to be X underscore test and Y underscore test. All right, so we're going to see how well this model did on the training data set, and we're going to see how well it did on the testing data set. All right, so let's go ahead and run this. Okay, so it was about 83.2% accurate on the training data set and about 82.8% accurate on the testing data set. All right, so let's go ahead and create a new cell, and let's use this model to make predictions about some individual based off of these columns or these features. Okay, but before that, I'm going to create a function to convert the data to number values. So here we're going to create a function to convert the data to number values. So we're going to convert things like, well, not age, but we're going to take an age anyways. We're going to convert work class education, relationship, etc. I think you get the idea. All right, so let's go ahead and create that function. So I'm going to call this function get underscore number, and it's going to take in age, it's going to take in work class, it's going to take in education, it's going to take in relationship, and it's going to take in marital underscore status. All right, and then we're going to convert these to their number equivalent. So I'm going to create a variable called number underscore list, and I'm going to set it equal to an empty list for now. And this list we will use to return the number associated with those parameters. Okay, so I'm going to type number underscore list dot append, and I'm going to append that age number to this list. So really, I guess I could just put the age, but what I'm going to do here is I'm going to put df, and then I'm going to put df where df dot age equals age, and then we're going to return age dot values at position 0. And actually, yeah, I think this is actually better to do it this way for sure. Otherwise, I may have to do some conversion if I just return the age. All right, but I'm not sure, but let's go ahead and continue for now. And I think that's good. All right, I'm going to highlight all of this. And I'm going to copy using Control C. And I'm going to do something very, very similar for the rest of these parameters for work class, education, relationship, and marital status. So I'm going to paste this about 4 more times. 1, 2, 3, 4. All right, and then just change a few things. So next, I'm going to find work class. And I want to find work class where work class equals our parameter work class, and then I want to return work class underscore num. All right, and then let's see what else we got here. We have education, so df dot education equals education, and then I want the education underscore num, and then relationship, and here I'm going to put relationship, and I want the relationship underscore num, and then last but not least, marital underscore status, and marital underscore status, and then marital underscore status underscore num. All right, and then I want to return that list, and I'm going to put it in a list. So I'm going to put in number underscore list. All right, there we go. So let's go ahead and run this, and let's create a new cell, and now I can finally test it out. So I'm going to create a variable called person, and I'm going to set it equal to our function get underscore number, and we're going to put in the number 23 for their age. Their work class will be a question mark similar to what's in the data set. So if I come up here, we can see that some of this data has a question mark. I could have put private as well. All right, let's go back down here. So I'm gonna put a question mark, and then they will have a high school degree. So they're a high school graduate, and they are unmarried. That's their relationship status, and then their marital status is never dash married. Okay, so let's just take a look at person. So I'm just going to show person. All right, so let's run this, and there we go. So now we can see the number equivalent. All right, so I think that looks good, and I'm going to put some comments here. So I'm just going to say that we are converting the categorical variables to numbers for the model. All right, so let's create a new cell, and now it's time for us to make the prediction. and see what income type the model believes this person will have. All right, so just type GB underscore CLF dot predict and then input person, and let's run this. Okay, so the model believes that this person will have less than or equal to 50K. All right, so this program isn't perfect, and I've only created a simple model. This program has some issues like the imbalanced data. The program used a small data set, and I didn't do any feature selection based off of any analysis. So this program can definitely be improved upon, and please take this program with a grain of salt, like I said before. All right, well, that's the end of the video. Thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. If you would like to become a supporter of this channel or just get the code, then I will leave a link in the description below for you. Thanks again for watching, and I hope you all have a great day, and I'll see you in the next video. Bye-bye.